And we're live! Hi, I'm Adam.
Hi, Andrew.
And this is our first ever Axiiio live stream.
Yeah. How about that?
You'll have to forgive us because we're new to this. We've never done a live stream before.
And we've got a lot of gear all around us, many cameras, and none of it is guaranteeing that this is going to be a good live stream, but we'll give it a crack anyway.
A red hot crack. And there's plenty of failure modes as I'm looking around. There's lots of things that could go wrong.
Indeed.
Yeah.
All right.
Hopefully it won't, but there you go.
Let's get into it.
Let's get into it. So, I guess the first thing we want to cover is the survey. Or should we talk about what we're going to cover?
Yeah, let's talk about what we're going to cover.
Yeah, okay. So, I guess I'll start.
Yes.
We're going to cover all of the components of the Axiiio system. So, what we call the core components, which is a Pancake, motor, and
all these things.
Receiver. Then we're going to talk about the support levels that we have for those components. So what you can do with them and what sort of kits we're going to be offering in the future. Then we're going to show you some of our prototypes, which we're pretty excited about. These are things that are very close to being finished and ready for release. We spent a long time over the years developing things so that we can release things in quick succession once we brought these individual components to market. And that's something that we haven't communicated very well. So we're going to show you some of those things. We're going to show you the app. We're going to do some stuff with the ProMoCo app. And then we're going to show you some of those prototypes. And then we're going to talk about the DIY support. So making the different types of rigs that you can make with the system, and the components that we're going to be offering that enable you to make a tilt pan rig by yourself, or a slider rig,
and also bits that you can make yourself. 3D print and so on.
Yeah. So because this is a flexible system and it's you're able to build your own stuff, we want to be able to support that, as well as supporting people who just want to buy a solution off the shelf, like a full tilt pan slide system, or something in that vein. We just want to be able to support all those different levels of stuff.
I think we should launch into talking about the Kickstarter campaign.
Yeah.
Because everyone's going to want to know what's going on.
The 800-pound gorilla.
Yes. So I think the truth of the matter is, unless by some miracle 50 or 60 people suddenly rush out and back a kit, it's not going to work.
Yeah, this Kickstarter is not going to be successful. So if you're watching, or if you know somebody that's thinking of that wanted to get a kit but they were waiting till the last minute, tell them to do it now.
Yeah, especially if you have about 50 friends in the industry
and they all want to buy it, then
we'll do anything.
Well, nearly anything. The good news is we are, if this doesn't work, if this Kickstarter doesn't work, we'll be launching again, hopefully in March next year. And we're not stopping our development cycle, so if all goes well, we'd be able to have an earlier delivery than the length of time that we've got now. I think we're saying in June.
Yeah, so delivery was
June.
So
it might be a month or two after that from a March campaign. So we're not going to stretch it out again, because there'll basically be less to do because we will have caught up with some of that work anyway. So things are progressing. We're not just going to stop because we've had an unsuccessful Kickstarter campaign. And we probably didn't reach out to enough people, and we didn't get people to review it. I think that's
I think probably the best thing out of this would be that we'll be able to send some equipment out to people so they can actually use it and review it before the Kickstarter begins.
Yeah, we've got very few of our these are manufacturability prototypes as well. So they're not pre-production per se. They're actually production prototypes, but we did a very small run of them so that we could do internal testing and make sure that all of the manufacturing processes were right. But there were so few of them, we couldn't really send them out to people while we're still testing. So we did have responses from people who said, hey, send us one, we'll test it. And we just went, we can't, we just don't have enough.
And we had to do our own filming. And we needed them for that.
Yeah, so like everything that you see today and on other things, like this shot here this is axiiio ping-ponging to and from one side to the other.
Oh, yeah.
You know.
There you go.
And yeah, there's lots of different... lots of different shots in our promo stuff was actually filmed using it. Not just the examples, but the examples of the examples. So axiiio filming axiiio.
Mm-hmm.
I think at one stage we had 3 stages of axiiio filming axiiio, which was a bit crazy.
That's
Maybe
great.
We should have explained that a little bit more. Because people said, oh, we want more examples. And we go, well, everything we filmed was an example of it pretty much. Mm-hmm. So yeah, I think we didn't do a very good job of it explaining.
So that the reason why we know that is because we did a mini survey, and we sent a survey out to our backers and people on our mailing list and our subscriber list, and we got back some responses. So thank you very much. Some of them were brutally honest, but it was really helpful. And thanks. We love the honesty. Yeah. And a lot of it was around issues like not fully explaining what it does, what part of the rigs were axiiio and what were just your off-the-shelf tripod. Issues like that. Yeah. And I think that's something we'll address in the next one.
Yeah. Also, a lot of people didn't really understand what was a kit and what you could do with a kit. So I think the next campaign will be more focused on, here's a tilt pan head, or the components that you require to build a tilt pan head, and here's how you assemble that. Here's a slider, and I think we're going to put a slider in the next one.
I'm pretty sure we are.
We're very, very close to having one for Kickstarter, so, and we'll show you that a bit later on. So yeah, we'll be a little bit more actual kit focused rather than here are some components, go away and make something. It'll be, here's something that you can use it for straight away. You don't have to, there's no more spend, just buy this kit and away you go. Rather than...
The slider was actually the stretch goal.
Yeah, that's right. Yeah, slider was a stretch goal. But we think that was a mistake. We should have just said, well, you want to get a slider, here it is. Here's a kit with a slider in it. If you don't want anything else, you don't have to get anything else. If you want to add to that at the end of the campaign through whatever fulfillment service we use, you could add motors and pancakes and all that sort of stuff at the end of it. So yeah, I think we're going to, with the experience of this one, we're going to be able to give you a much better selection of options and also more information about those options. I think it's lacking. We link to our website for a lot of stuff in the campaign. I think we'll probably build those pages into the campaign, or those sections into the campaign, so that all the information's there in one place. You don't have to link out. So, yeah.
But I think we should get started.
Yeah.
And the first, I think it's important to start with the core components, because that's really the system.
Yeah.
The reusable components, and they're fascinating. And here they are.
Ta-da! Shall we go?
Where do we start?
Should we start with that?
All right. Start with that.
So that's the receiver. And I'll show you on this little camera here. This is our receiver. Is it focusing? Yeah, it is. I'll get a bit of light on it. So you can see how big this is. I've put my hand behind it. It's probably, I don't know, half the size of a cigarette packet. It's very light.
It probably weighs as much as a packet of matches.
A bit more, but not much more, because it's made, because all of our housings are made out of carbon fibre. We're able to keep the weight very low, and it's neat. I mean, it'll just fit directly onto a hot shoe. We've got a hot shoe adapter. I don't think I've got one of those out to show you, but there's basically a little adapter in here that will enable you to mount it onto a hot shoe of a camera, and we can mount it on a 15 or 19 mil rod using one of our clamps, which incidentally you can just put onto the rod. You don't need to take everything off the rod and slide this on. You can open it up, put it on the rod, sort of semi-clamp it down so it's still loose but it won't open, slide it up and down, get it into the position that you want, cinch it up. A lot of time went into designing these to make
I just want to say Adam tends to just breeze past these things, but this is an example of his quality engineering. This little gear here, just by itself, is very, very special, and you can't find many things like it.
No.
It clamps in two directions, basically.
Yeah.
You have a release mechanism, so you set it around your rod, and then you can tighten that so that it sits securely on the rod, but then it has another little foot here, so when you slide something on it, you tighten it a little further and it slide locks it onto that as well. It's very, very clever.
Yeah. It slide locks in, and it's I got working professionally and having to pull a rig apart to put a motor on or another bit of equipment is so frustrating, because you go, oh no, I forgot to put this on, and then you have to dismantle the whole thing and then reassemble it all with that, and then you realise you put it on back to front. It's like, oh my God, I have to pull it apart again. Especially when you're just building, you have an idea for a rig and you're building it out for the first time. It might take 2 or 3 goes to get it right, and it just makes that seemingly simple thing that much easier by having a clamp that you can pull on and off. The other thing with these is they're 15 and 19 mil compatible. So we've got these are actually 3D printed inserts. We don't have any of the actual inserts, the manufactured ones. This is one of the few things that we haven't had manufactured yet. But these inserts snap in and out. Actually I'll show it on this screen. These little inserts snap in and out. So that's for the 15 millimeter clamp. You take those out and you can put it on a 19 mil clamp. So people who've got bigger cameras and larger rod systems, 19 mil, it'll work on both of those. But that means that clamp is universal to all of our equipment. So you put it on you can mount this onto a clamp.
It's also on the
on the motor. It's the same clamp. And you get, every time you buy a motor or a receiver, you get a clamp with it. And there are other things that we're going to be using this clamp for as well, which we don't have examples to show you today, but I will. In the coming months, we will.
And what Adam said there about his experience on set and workflow and time wastage is really important, because solutions for efficiency throughout the system, just little tiny things that I find fascinating. It's the little clamp on the bottom of the Motion Pancake here is just a simple lever, and it slide locks the motor onto that. All these things make it.
Is the insert 3D printed?
Oh,
this insert in the clamp here, at the moment, is 3D printed. This was just a question that came up. That is 3D printed at the moment. However, these will be a plastic injection molded part. So we need to work out what the best material is for that before we make any molds. So we've been experimenting with the materials the best possible material for that for that little insert part. That's why that's still 3D printed. It may well be, and these work quite well. These are just PLA. They work really well. And at one point we were thinking, well, we'll just print them because we've got 3D printers and we can print loads of them. But because it's an integral part, we will injection mold it for the actual Kickstarter. It may well be that the first few, just depending on how much money's left over for tooling, the first few might be 3D printed. But if you do get a 3D printed one, we'll for free ship you some injection molded ones once we've got them. So yeah, that was a quick question there. So back to the receiver. This little guy has got 7 ports on it, on the front of it, and these are LEMO equivalent, 0B LEMO equivalent connectors.
Do you have any cables lying around?
They're metal. No, I don't think I do. Oh, on that, we'll show them on when we show the tilt pan. Right. We'll show you these being plugged in a bit later on. But they're metal. They're positively locking, and they are very, very reliable. And again, for workflow, for reliability on sets, having that type of connector is really, really important. You don't want a little Ethernet connector. You don't want something that's plastic that can pull out, or the end will break off if you drive a dolly over it.
Ethernet cable connectors, the little plastic tab breaks off, and then
they're stuck in there.
Using a bit of blue tack to hold the damn thing in.
That's a professional connector, and that's what you want on something like this. I mean, even if you're not working professionally, it's just, I nearly swore, but it's very annoying when it falls out. And if the system isn't robust enough to handle that, it'll freak out and you'll have to start again. This is, we think, robust enough to handle that sort of thing, but...
not to mention, it's a very satisfying little snick.
Yeah.
It goes snick-click when you put the cable in there, and you know it's locked in, you can feel it.
Yeah. I'll just talk a little bit about the ports themselves. So coming back here, there's 4 on this side. They're labelled A, B, C, and D, and they are the motor ports. That's what the motors connect to. Now the motors are, I'll talk a little bit more about them, but they're not stepper motors, they're servo motors, and that's quite important from a control perspective, and that's why we're able to make it so small, this system's so small and light. So you've got 4 of those. Each one of these can handle continuously 3 amps at up to 30 volt output. And this little receiver automatically detects the type of motor that's plugged into it, which is a little hint for there may be other types of motors for larger jobs coming. It automatically detects the type of motor and just works out exactly how much current and voltage to give that motor to control it correctly. So there's a lot of smarts built into those 4 motor controllers to make them very, very flexible. And this is all in-house stuff. It's not, it's stuff that we've developed in-house. It's software and hardware that we've developed in-house. So these are custom boards inside. It's a 3-layer board. This thing is packed with electronics, as you could well imagine, to make it this small, and to be able to give it the ability to run 3 amps at 30 volts 4 times. So that's the motor ports. We've got a power input, which is the red input, and the leads are red. So when you're plugging things in, they're color coded. So you don't know, oh, which port do I need to plug it into? It's red, red goes in red, blue goes in blue, yellow goes in yellow, black is motor. You just need to make sure you get A, B, C, and D right when you plug it in. So red is power input. The blue input is what we call the multi-comms port. Now that has a USB port and a serial port built into it. The serial port is for a whole bunch of other devices that we're working on. The USB port is for flashing the unit. So if you're going to, when you're updating firmware, that's the port that you use, and you get a flashing cable, a USB flashing cable with it. Plus, further on down the road, once we've got the USB host to work in this, it will be able to control camera parameters. And that's quite important because it means that from the app, you have one solution that does the control of all of your motors and the control of your programs and your motion. Plus, on another screen, you'll be able to change your camera parameters, which means you don't have to touch the camera.
Which is important, as you've explained,
Yeah.
on set, when you have the camera in the position that you want it, and it's very hard to see the back of the camera.
Yeah. The number of times I've been in a room and I've had to put the camera almost against a wall to frame the shot properly, and then gone, I can't get to the camera. And I'm sure plenty of you have had that issue as well. So that's that port. And then the yellow port is what we call a multi-IO port. And that's got a bunch of digital IO that we can use to connect to gimbals. We can use that to connect to triggering components. So that's where you plug your external camera trigger in. And the starter kit and all the other kits come with your choice of camera trigger lead. So that when you're doing, a time lapse, it can trigger the shutter. When you're doing video motion, you can trigger the video recording and stop the video recording when you get to the end of it. And yeah, like I said, it can also control axes of a gimbal, camera stabilized gimbal. And what this means is you can plug your camera into the USB port, that port into the gimbal, and then walk away with the app or one of our hardware solutions and have a second operator that can control the camera as well as the gimbal settings and tilt and pan, do whatever else you need to do with the gimbal. And there's a bunch of hardware that I've been working on for a long time, which gives you the ability to control via PPM axes of gimbals. And we're very confident that we can talk to most of them that are on the market right now. So yeah, all from this one little box. That's sort of...
And because of the way you've designed it, a lot of the stuff is all just firmware updates.
Yeah.
So it's completely software defined, and we can expand all of the feature sets just through firmware updates over time.
Yeah, firmware and updates to the app.
Yeah.
So yeah, that's the receiver. It's the hub. It's a really versatile little unit. It's really been designed from the ground up to be as versatile as possible, with a lot of functionality that we'll be implementing over time. And it's all there. You don't need to buy anything else. On the website, on the receiver page, we've got an updates list. A lot of people have asked about our timing for the roadmap, and we don't have one yet. I think it's something that we're going to work on, though, because it's been asked a lot. When are you going to have these things out? But most of the things in there, unless it's otherwise stated, it says you will require some extra hardware to make this work, are already built into this. And it's the vast majority of those features are already built into this.
What's the range of the receiver? And is the software capable of follow me?
Aha.
Okay.
Well, the range, it's 2.4 gigahertz Wi-Fi.
Yeah. So line of sight, probably 100 meters.
Yeah. Yep. Give or take.
100 yards, say. Line of sight with the Wi-Fi. However, these aren't defined by Wi-Fi, and we have other radio solutions that we can drop into these. So
we'll get on to future things.
So that we'll loop back round to that question of the range, because we've got some options there that can give you, crazy big ranges. What was the other question, Sam? Sorry.
Is the software capable of follow me?
That's another thing that we've got in the works. So it's object tracking, and we've invested in some AI hardware and equipment to make the system follow targets and focus on targets. So that will be an add-on which will plug into the serial port, or it may work wirelessly. More likely it'll be a wired solution, and that will track objects and follow them around the room, coming at some point. We haven't put it in our roadmap yet because we've only really just started examining it, but it doesn't seem to be, it doesn't look like it's going to be super hard for us to do, and it's something that we really want to make happen, because how cool is that? I mean, you just go, hey, here's a screen, follow that person, focus on that person, all right, follow that object, and then the camera will just, you set up your easing between those 2 points, and it just goes from that point across, eases over to that one, and then focuses on that target. So it would be a target-based sort of app screen where you tap on a target and it will just go to that, to and from those targets. So yeah, that's that one. All right, we're getting the
wind up.
We've got to keep moving on. Pancake.
Okay. Pancake. There's two.
Oh yeah.
So the thing about the Pancake is, it's very. Firstly, what the hell is a pancake? It's very deceptively simple, but wherever you can put one of these, you can attach a motor to it and control that axis. So on a tilt pan head, that would be the pan, and that would be the tilt. And other things like the slider.
So show it on the camera. There are two types too, as well. I think we should talk about that. So this one is the capstan style of Pancake, and you can just see in there's that rope capstan. Basically, you wind a little bit of rope around that, and then it comes out of these two little pulley gaps here. So you go in one, you wrap it around 2 times, 3 times, and then it comes out the other side, and then that will just pull itself along that bit of line, which means you can make a really long dolly, attach it via this, and then just get it to pull itself along.
You can actually see the skateboard dolly example that you built on the YouTube channel.
Our beer delivery robot, we did one using this, I think it was actually this Pancake, using this Pancake. So that's really quite flexible from the viewpoint that, put it on a skateboard, away you go, put it on a Flying Fox, away you go. However you want to do that. It has some downsides. One is it can slip a little bit, particularly if it's under high load. So making it climb vertically is pretty hard to do. It tends to slip. It certainly can't lift a lot of weight vertically because it will slip. So it's more for a horizontal motion. And the other downside is it's a little bit less accurate than our belt drive version, which is this guy. And this one has, if we have a look at the camera here, again, we switch to that one. Yeah, you can see it's got a tooth belt in there, and then it's got 2 guide wheels on the top. So the belt comes in here, wraps around the capstan, comes out here, and it engages with these belts. So it's far more accurate than the rope version, just simply because it's positively engaged in that gear.
And this one also has a quick release plate.
Oh yeah, we put a QR plate on the bottom of this,
because it's important to know that you've got mounting options on that side of the Pancake.
Yeah, there's 3/8 and 1/4 inch standard mounting holes on the bottom of this that you can connect to, so you can connect it to your tripod. So we put this one on, and there's a 1/4 20. There's a quick release plate. You just put it on, and that's it. There's your pan axis. So if you imagine that was your tripod, and we've got some ball heads that we'll be offering as well with this quick release system. This is just I think it's Nova Swiss release system on the bottom. You can just mount it onto your Pancake and onto your ball head, and away you go. You've got a rotational axis straight off the bat.
And it's important to note that it integrates with standard mounting systems, photographic mounting systems.
Yeah. So if you've already got Nova Swiss clamping, and a lot of people do, then anything that you've got that's Nova Swiss will work. So we'll come to the motor because we're getting more wind up. Motor is, you know, we can mount it on a rod and have it as a focus motor.
Or zoom.
Or controlling your iris. This is a 0.8 mod gear for those of you who've got 0.8 gears. The gear is actually interchangeable.
Which is another thing.
So
no tools required.
It's just got a little thumb screw on the back. You focus. It's focused. It's got a little thumb screw on the back. The gear comes out. It will go on either side, and in the software you can tell it, because when you flip the motor, particularly on a lens, it now turns in the opposite direction. You just tell it in the software you flip the lens onto the other side, and it will automatically just track to the lens marks that you've already put on there. And this also means that you can replace the gear with another one, and that makes the Pancake operate in a high torque mode and a low torque mode. So it can go really fast, or it can go really fast. It doesn't go slow, but the smaller gear gives you more torque. And that's the one that we recommend for sort of tilt and pan axes, because it gives you much more precise control using that smaller gear.
Just show that, show that side.
Oh yeah. Just you just screw in the thumb screw.
All they can see is your hand.
Oh yeah. So yeah, you just screw in that thumb screw.
There you go.
And it locks down on the gear, and that's it. I think that's on the right side too.
See, I think it's really hard to communicate these concepts of the way the system's designed to be so flexible and toolless wherever possible.
Yeah, toolless is a big deal. So once you've changed your gear out to the small one, oh, incidentally, people will probably have noticed that this is a brass gear in all of our promotional video. The actual one is made out of a plastic, and I can hear people going, "Oh, metal's better." Well, actually, in this instance, it's not. Brass to aluminium interface, which we thought would be good, is actually really quite bad, and we've worn out most of these Pancakes because, firstly, there's a reaction going on between the two metals, so it's corroding and pitting, and secondly, it takes off all of the hard coating off the gear if we use brass. We thought that the brass would wear, but in actual fact, the aluminium wears, because the aluminium on spec sheets is harder than the brass. But the reality is the brass is damaging the aluminium through basically rusting it, and it's pulling out little chunks of the aluminium, and it's made most of our Pancakes not usable. So we've changed that to a resin, which is a bit softer, but it doesn't wear. Now that we've been using the resin gear on the sliders, which have been doing far more work than these, and they've hardly worn. So it's a much better solution. So if you have backdust and it gets there and you go, "Oh, I don't have a metal gear," that's why. It's actually a better material for this.
Yeah.
Is there a weight limit on the motor?
Yep.
Yeah, there is. Yeah, we'll get to that one in a sec. So yeah, and this is how it works. You've got this little lever. You put your motor in. You slide it in. You engage it. You pull it back a little bit to get it nice and tight, and then you lock the motor in, and as you can see, there's almost no backlash in that at all. There is a little bit, tiny little bit, but it's really minimal. They've been engineered to be quite high quality, and the worm drive in there, the worm gearbox in here has taken an enormous amount of time to perfect for this application.
Yeah, we should talk about the motor in detail.
Yeah.
The gearbox and the encoder and so on.
So This is a servo motor. It's not a stepper motor. If this was a stepper motor, it would be a lot bigger to move the loads that the system can move. It's got a coreless motor, a coreless brushed motor in there, which is very efficient. About 94%, I think these motors are. So, which is into brushless territory for efficiency. That means that all the energy that we put into it actually goes to rotational motion. We're not sapping vast amounts of energy by having, an inefficient motor. And then the next bit is the worm gearing in the gearbox, which is also as efficient as we can make a worm drive gearbox. Now they're typically not very efficient, but through a long process of researching materials and trying different materials inside this gearbox, we've gotten the friction right down. We've also got what's called stiction right down in these as well, which affects the performance of this type of motor. If we can get the stiction as low as possible, it's great. So there's a hybrid gearing system inside this head, which is very special and has taken an awfully long time to engineer. And then on this we have an encoder as well. So this is what's called a closed loop control system, whereas stepper motors generally aren't closed loop. They're open loop. It just pulses the motor so it turns. Now stepper motors are great. They're really, really awesome bits of kit for control, but they have one Achilles heel, which is the faster they go, the less torque they produce. And that's a real problem if you want to go fast. And some of you may have bought stepper motor based systems and are complaining that they don't go very fast. That's why. If you want to go fast, they're going to get big and heavy because you need larger motors to turn. You have to gear them down less, and to do that you need larger motors to go faster. So efficiency really drops off with stepper motors the faster you go. Whereas with servo motor, the torque curve's pretty flat all the way through it. With these guys, they do drop off at the high end, but you're going so fast by that stage, it's stupidly fast. So you probably would never have to use it. And these are actually limited. They don't ever go to their highest RPM, so they stay within a nice torque band.
So speaking about torque bands, we need to talk about weight limits and how fast it moves.
You can fairly easily put a 10 kilogram load on this and turn it this way. When you go that way, you can still put a 10 kilogram load on it. You'll need to be close to the center of the axis, and you need to make sure that the weight doesn't stick up and down. And that way you don't want a large swinging mass out here. So we've put the absolute maximum weight of the system at 10 kilograms, but that's really going to depend on how you set up the weight, where the center of mass of that object that you're moving is. Now, it'll still move it. You might have to turn up your ramping or the ease in and the ease out. You're not going to be able to just go whoop and whoop. So accelerate really fast and then decelerate really quickly, because you'll be putting a lot of strain on this little interface. And if this clamping system isn't tight enough, going in the direction that it can spit the motor off the end, it can actually move the motor out of engagement if you're accelerating or decelerating too fast. I've only done that a few times in testing with ridiculously heavy loads, or if it hasn't been tightened up enough. So in the early days before we started putting thread locker on this to make sure it didn't come undone, that could happen, but we fixed that with as part of our manufacturing process. So yeah, 10 kilograms is the absolute maximum, and that's with the small gear. You can't do that with the large gear. But a more realistic weight, now 10 kilograms is about 20 pounds.
Yeah,
roughly.
22, I think.
22 pounds, something like that. More realistically would be 7 and under. 5 kilos is a good weight.
Which is about 10, 11 pounds.
So this, if we switch the camera to the tilt pan that we've got here, this is a, no, sorry, that filming it, Sam. Yeah. This is a GH5 with a whole bunch of stuff hanging off it. So it's got a focus motor, it's got a video transmitter, so it's heavier than just a small camera. All up, I think that whole rig from the pan axis all the way up weighs under 5 kilograms in total. Works beautifully. You can put a much bigger camera like this one, which is a D800. Sorry, this is a D810. So this sort of mid-sized body on there with a large lens handles it no problem. It goes up to, 6 to 7 kilograms then, and it works fine with that. We've put Ursas on it. We put an Ursa, an Ursa Mini.
Ursa Mini Pro G2.
What else have we done? We've done a large Sony. I can't remember the name of that. And of course, we built a red plastic mock-up, which we filled with plaster and metal to weight it, so it was the same weight. We put that on.
It's over there.
It's over there. I'll just grab it. We put that on, and we swung that around, and we gave it some googly eyes. And we'd like to introduce you to our friend.
Here he is,
Haxiiio. Hello. Yeah. So this I think weighs a lot. But yeah, it handles this fairly easily.
Again, there's a video on our YouTube channel that shows it whipping around.
Yeah, it moves pretty quickly, spectacularly quickly actually.
Is there a warning when you're approaching the weight limit?
No, but that's a good idea.
Yeah.
That's a great idea. What there is, though, is when you set up a rig, when you're building a rig, you tell the system whether you're a low, a middle, or a heavy weight rig. And then it will, when you calibrate it, it will tailor the calibration for a heavier load. You don't have to tell it that, but what it's going to do is it will limit the speed that you can accelerate and decelerate at. So you won't break things if you do that. But I think it could probably work out what the weight limit is and give you a warning when you calibrate it saying, nah, it's too heavy, take it off.
Yeah, absolutely.
Thanks for that. That's great. All right, I'm going to put this back over here. Have we covered everything on the motor, do you think? Or have we got more?
I think so. We showed the gearing. Yep.
So
we were just going to.
We're just going to set up a. So let's put the motor on that guy. Put that on there like that. We don't have a lens on this camera, but then you just put your camera on here.
And if you got this guy.
Oh yeah. We don't have another motor to put on but there's no lens on this anyway.
We got this guy. Then we can actually mount him here, can't we?
Yeah, just as an example.
Yeah.
Show you.
Just as a demo. I think you've got it mounted like this in one of your videos.
Yeah, I think so. Yeah.
Anyway, we can mount him there.
Yeah.
Cable it up.
Nice and simple. Now you've got a pan axis for, doing pans. And so I've just disconnected that so that we can turn it. This is, you can do a lot with a pan axis. I'm actually surprised at how many shots we've actually done with pans now that are really, really good. You think that sliding is the king, but in actual fact, particularly for time lapses, panning is really effective because you're getting a lot of motion at distance. Whereas if you're sliding, you kind of need to be fairly close to the object, or you need foreground and background so that you get some parallax to show that you're actually moving. But panning, you don't need that because it's moving, it's panning across the scene. And you can do, we've done some composite work on on our YouTube channel. There's a composite that we did of
The beach?
of me at the beach,
Yeah.
yes, where we panned across and the clouds are moving really fast because they've been filmed with a time lapse, but I'm walking and talking in that scene in real time. So we've got these two time zones, and the ProMoCo software, which we'll get to a bit later on, makes that really easy. Makes it really simple to.
Because you can configure that motion as a motion program, and then play it in time-lapse mode. So you're taking the time-lapse, and then you can just replay that same motion in real time. And the software makes it really easy to calculate how that should work.
Yeah. Basically, you create a program, and then you can run it in any of the modes, and it will come out. If you've put the correct frame rate in, it'll come out at the same with the same motion. So that time lapse will have exactly the same motion as your video motion, or if you're doing a stop motion animation and you want to put some live footage into stop motion, same thing. You do your stop motion, then when you do the real-time video, it will be synced. The motion will be synced with the time lapse or the stop motion. So yeah, that's just a really, really simple way of doing it. Obviously you need to plug all of this in as well once you've done all.
So that's basically, on our Kickstarter campaign, that's basically the starter kit.
Yeah.
You've got a motor and a pancake and a receiver, and if you have a tripod, it's as quick as that to build a pan axis.
Yeah.
And then have programmable motion.
Yeah.
But the cool thing about axiiio is that you don't just have a pan axis. You've got a motor and a pancake that you can then use to do a tilt pan.
Yeah.
Sorry, a tilt, and then a roll.
Yeah.
The bit that's up to you is the components that you've hopefully already got to assemble the rig. The L bracket and other bits like that.
Yeah. So
I think,
we're done with
yeah, okay.
Can we briefly show the software?
Yeah, we're coming to that.
Do you want to want to show the app screen real quick?
Yeah,
Yeah,
okay.
yeah,
Yeah,
go
sure. We've got
it has a program running at the moment because it's in front of us going back and forth, ping-ponging back and forth. And so you see two axes are actually moving. Oh, you've got focus, slide, and pan moving. And while a program is running, the screen is actually animating to show you the position of the rig. And those millimeters are actually accurate. So,
Yeah.
and you don't have to, the app just works that out. App and the receiver they share information and work out what the distance is and what the current position is. The pan is in degrees.
If you, just go to the big screen. You can see that as it's moving, you can see it counting degrees and all of the rest of it. And then you can see those marks that it's coming across, which you can drop onto those axes to give you cues for when you're moving around to get to things manually. Or, if you're a director and you want to be able to see something coming, you can call out when it's coming, which we just used for a shoot, which was really, really cool.
Yeah.
We just dropped marks in spots where the camera was going to be when we needed talent to be doing things, and you could just watch that mark coming up and go, all right, cue, action, and then that person would be able to go when the camera was in a particular position.
But I was quite chuffed because you were running the program because it was synced to a piece of music, and as the program was running, you went, drop a mark there.
Yeah.
And it did it.
Yeah, it dropped the mark on the line. All of a sudden, we've got a mark for talent while we were doing a rehearsal. So it's got lots of little tools like that for professional use cases where you can just drop things in. There's a panel in the middle here, which I'm just switching through now, which has a whole bunch of different stuff in it. We're actually going to show you a program and how to do a program in a minute. But we just wanted to cover some of the hardware that we're going to be doing. So some of the prototypes. So if you can just hang in there for another, 10 or 15 minutes while we show you that. It might take us longer to show you the prototypes, but and talk about those.
So at the moment we have an iOS app. We do have plans for an Android app, which will be out before the next Kickstarter.
Yeah, hopefully that'll all be done. No, well, not hopefully, it will be done.
Yeah,
Yep.
we definitely want the two major platforms.
Yeah, one of the reasons the date was in July was to give us June, was to give us the ability to ensure that we had an Android app out. So
Yeah.
All right. So
What do you want to talk about?
Should we talk about the 3 levels of support?
Okay.
That one.
Yeah.
So we've talked about these components, the basic components of the system. One of the things that the survey that we did has turned up is that it's not really clear. It's not 100% clear how to use all of this. So we always intended to do this, but we didn't communicate it very well. We have a couple of different levels of support for the Axiiio hardware. Now, the first level of support is kits. So you buy a kit and it has absolutely everything you need in it to do a particular task. So an example of that would be, a tilt pan slide kit. Got everything that you want in it. You just take it out of the box, set it up for the first time, away you go, done. The next sort of level is what we call rig builder components. So things like L brackets and accoutrement that you can use to attach to the pancakes to create other types of motion, like a pan or a tilt or a tilt pan.
The ball head and the tripod and stuff.
Yeah, ball heads, tripods, stuff like that you can mount it on, that we will have on our web store, and we'll probably have a fair bit of that in the backer part of the next Kickstarter as well. So you can kit it all out with standard hardware as well. Remember that these are Swiss something clamping system as standard. So anything that you've got that'll fit in that clamp, you can use. And if you don't have the bit that you want, we will have selections of equipment that you can buy. Cages, rig cages, that sort of stuff.
And not only that, if you don't want to buy it from Haxiiio,
Yeah.
you can buy it from anyone. They're common throughout the market.
Yeah. So that's
that was another one of your core philosophies, was you didn't want to buy a piece of kit that was one single purpose, which a lot of the current inexpensive motorized components are. They do one thing, and you have to buy it, and you can put your camera on it, but there's nothing about it that you can really change.
Yeah.
Yeah.
And the third level is what we call DIY support, whereby on our website we'll have STL files, stereolithogram files that you can 3D print yourself. We'll have some instructions on how to build brackets for sliders and how to build different types of rigs. And we've got some examples to show you of things that we've built, and we will be putting on our website with little instructions, and we might put them on Instructables as well, and a few of those other DIY sites.
Shall I go and get some?
Do we want to do that, or do we want to do the slider first? Do the kits first?
Oh yeah, right. The big one?
Yeah, maybe the big one. Here, Sam, could you take these off, because we're going to be bringing a big old bit of kit over. I'll leave the camera here. Will that fit on there, or you? Okay, so
Which way do I want to put it?
probably with that facing that way. Yeah. So,
Be good?
yeah, that's all in the shot. So this is our prototype tilt pan rig, which has been designed around the pancakes. But these are permanently attached to it, and it's got a wiring harness that's permanently installed on it as well. Well, I mean, you could pull the harness apart and take the cables out if you wanted to reuse them, but it's sort of been designed, has been designed to be a permanent fixture. And you would just take this and mount it on a tripod or mount it on a slider, and Bob's your uncle, away you go. And it's got everything built in it that you need to get going. and you can buy it with motors and receiver or without motors and receiver. So you just simply unplug all of these plugs on the front, take your receiver off and go and do something else with it, and the motors, and then when you're finished, or you want to use it again, I can't see the orientation of this because it's in front of me. Yeah, there we go. Then when you're finished and you want to go and use it again, you just bring those back and plug them in. And the software remembers that rig, so you can load that rig back up again.
Yeah.
And use it again. So it's not like I have to go through the whole setup process again. You just pick it from your list of rigs that you've got. That's the one I want. Calibrate it, and you're good to go. So that reusability, that flexibility is still there, but you've got a purpose-built rig. Now this is all carbon fiber components, so it's lightweight. We've built in everything that you need is on this. So up here we've got like a power output section. So you've got a couple of power outputs, and you've got a trigger lead, which is this guy. So if you're triggering it, you can trigger your camera, and it all comes through the center of the axis of the tilt axis, so that this can rotate freely without any cables getting snagged or any cables in the way, or any of that sort of stuff, which if you've used systems that have cables before, that can be a problem. Now there are systems out there that have Bluetooth connectivity, and it's something that we looked at, but all of the components get larger. You now need to put a battery in all of the components, and they get even larger still. And the third thing is it's not very reliable. In our experience, we've had lots of trouble connecting particularly Bluetooth devices up to other bits of hardware. When they disconnect, it's very hard to reconnect them, particularly if you don't have a screen and you can't see what's going on inside the unit. That's why we went with leads, because it actually makes it smaller. It also makes it a little bit more reliable. Well, not a bit more reliable, it makes it much more reliable.
Someone in the chat says, I can't remove the pancakes, question mark.
You can.
Oh, yes, you can.
You can remove these. You have to unscrew them and take them off this rig, but you need to take all of the wiring out. This, if you imagine, this is a solution that you'd buy if you want to put a tilt pan head in your kit. You can take the motors off, right? You take off the motors, and then you can put that on another rig. You can take off the receiver, take that away, unplug it, put that on another rig. So if you wanted to build a fizz rig out, you just need a motor lead and a power lead. Oh, and these kits will come with a couple of extra leads so that you can do that. It's not like you have to buy extra leads. It will come with the kits. So you wanted to do a single axis run and gun pull focus rig, take off your receiver, grab one of your motor leads, plug it into power, grab one of your 15-19mm rods, set it up, and away you go. Or you want to put that on, I don't know, just a pan axis. You grab a motion Pancake, which incidentally are fairly inexpensive. They're not, we've priced them so that you can buy a couple of these. They're not going to break the bank to buy. So if you want to just take a pan axis out on a shoot with you, you've got a second Pancake. Rather than disassembling all of this, which you can do if you want, right? But rather than doing that and then reconfiguring it to go and do a pan axis, we think it's a lot easier just to have another pan axis. The high end kits, the top level kits will have an extra Pancake with them anyway. So the answer to that question is yes, you could take it off, but it's going to be a bit of a pain in the bum. Our recommendation would be don't do that. Leave this set up. Use the second Pancake.
Take the motors off.
Take the motors off and the receiver and use them elsewhere. That's what we'd recommend.
Are there batteries required for each unit?
The power.
Okay, so power is another bugbear of mine on sets. I absolutely hate having 12 batteries that myself and an assistant, often two assistants, have to keep running around and checking. It's awful. And one goes flat, it's like, oh, okay, we better check all the other ones, make sure they're not going flat. It's nasty. So this guy has one power lead in, and everything that you see here is powered from this one site. Including the camera in this rig. So we've got a power output here. We put a dummy battery in these GH5s. So the rig that is bouncing to and fro right now, that one right there, everything is powered from one lead, including the video transmitter. So it's got enough power outputs built into this rig to power anything that you can throw at it. And it's basically put the camera in, plug the camera into all of the various bits and pieces, and away you go.
So the receiver itself can power 4 motors.
Yeah.
And then, with the addition of power distribution, you can also, it's got enough capacity so that you can power the camera itself as well as video transmitter and so on.
Yeah. And that's all built into this rig. Now you can plug that into the power supply that comes with the system. We've only got AC powered, so plug into the wall solutions at the moment. We have been working on a V-mount system, but any off-the-shelf V-mount that has V-mount power output will work with this. So you just plug it into a V-mount, away it goes. 14.8 volts, 14.7 volts, or whatever that voltage is. And this works out that it's got 14.7 volts plugged into it, does everything else for you for the motors, and you just have to make sure that your accessories run on 14.7. Oh, one thing is there's this little box up here. We'll have a power converter in it, and we may put another one in here. Not may, we will put another one in here, and that will be able to give you other voltage ranges. So you'll have a selection of things that you can clip on. So this has just got a couple of screws on the front and back. You can slide it off and put another one on. So if you wanted a 12 volt output and a 5 volt output here, you could do that. And the same here. You will probably have a range of voltages that you can output here. So you've got power on the inside of the tilt running through the central axis, and then you've got power on the pan side of it as well. So if you're hanging things off on the outside that are feeding through, you don't have to run a power cable back out through the axis. You've got 2 spots where you can run power.
And if, for example, you're doing a very long time lapse, it will last for a couple of days.
Yeah.
In time lapse mode.
Yeah. With
one V-mount battery powering the whole rig.
If you add a camera, so that's the axiiio system. If you add a camera to that, with these GH5s, I get about 8 hours with the camera powered up. So on one V-mount battery, which is pretty good. If you wanted to keep a camera on that's a mirrorless camera where the screen's on or the shutter's open the whole time, they use a lot more power. If you get something like a D810 for time-lapse, which goes into a low power mode when it's not taking a picture, it will run for days because that draws almost no power when it's just sitting there waiting for you to push the trigger. Mirrorless cameras use more power, so I don't tend to use mirrorless cameras for time lapses unless we have to match frames. So you want to use the same sensor and the same lens to make sure that everything's in sync. But yeah, it'll run for days if you use a camera that's got a mirror that raises rather than a mirrorless camera. They run a lot.
What else do you want
better.
Show?
What else?
Let's
move on to the next one. What's the next one? Should we talk about ProMoCo now?
Sure. Okay.
Or
anything else you wanted?
Should we do those and then do the prototypes that we've got coming up? All right. ProMoCo.
ProMoCo is the. Actually, pull it up again. It's currently running. Do you want to start from if you stop the program and then make a program? Do you want to show?
Yeah, sure. Okay. Or do we want to do like a calibration cycle? Or
oh yeah, show
should we do a calibration cycle. All right.
So
pause that. Oh, it didn't pause. Pause. There we go. Go back to the beginning. Okay. When you first connect to the unit and it hasn't been calibrated, it
Yeah.
automatically detects it. And
So, do we have?
tell me what to do.
Well, let's show the. We could show the whole thing if you want to. We need to be able to power cycle it.
Oh, I can power cycle that. Give us a second and I'll power.
All right.
I'm just going to shut the app down completely. So we'll go from the beginning again. What I might do is just turn Wi-Fi.
Just.
I just turned Wi-Fi off because we're trying to start from scratch, so it's not connected. So I'm just disconnecting
right.
just going to disconnect the unit.
We're turning the thing off.
And back on again.
It was sort of simulating what would happen if you turned up and
just
plugged in the receiver. And if you can see it, I don't know if you can see it clearly from this camera, but it's flashing, waiting for a connection.
Yeah, there are 3. Oh, actually, do you want to pass me the receiver and I'll show the LED on this little camera. Oh, there we go. Can we see it here?
Can't really
It's
see.
a bit hard to see.
Right in the middle,
But
where the logo is.
In the middle of the axiiio, there's 3 eyes, and the dots of the eyes, 2 eyes go up, 1 eye goes down, and those dots actually have little blue LEDs in them. And depending on what you're doing, they flash different patterns to tell you what mode, what the receiver's currently doing. So even if it's disconnected, those lights will be telling you something about, you know, what's going on. And at the moment on that one, they're flashing on, off, on, off, on, off, on, off, which is...
We do have a demo of that on the YouTube channel.
Yeah, that basically shows you. So, Sam, do you want to just go to the app screen? I better just turn Wi-Fi on.
Yeah, make sure that's on. All right.
Deconnected.
All right.
We'll forget this next word. I'm just going to forget that network. Right, there we go. Right.
All right. So let's pretend.
So we're just pretending that we're powering the unit up.
Yeah.
And we hit ProMoCo.
We're
launching the app. Do you want to just make it large, Sam?
Oh, that's the other thing. So because it has already connected to that receiver, it wants to reconnect to it.
Yeah. So
rather than scan the
QR code.
Yeah.
So if you were starting for the very first time, what it would do is it would go, all right, you've never connected to anything, scan the QR code. And there's a QR code on the back of the receiver, and you just waft your device across the back of the receiver and it joins. Again, we've got that on the website. We've got that in the Kickstarter campaign. There's a
video on the YouTube.
There's a whole bunch of videos showing how that actually works.
It just means you don't have to fiddle around with Wi-Fi hotspot host names and passwords.
And that sort of stuff.
Just an easy scan of that QR code.
And one thing to point out here, I think is really important, is you're not joining an external network here. You're connecting directly to the receiver. The receiver is the Wi-Fi hotspot, and it will only allow one connection at the moment. So once you're connected to it, nothing else communicates on that network. So it's dedicated. That bit of Wi-Fi is now dedicated purely between your mobile device and the receiver. So yeah. So if we go back to the that screen, so it's wanting us to join. So we click on join. Yeah.
Yeah.
We click on join. And shouldn't it have come up with the...
It did join.
It's joined?
Yeah. There you go.
Oh,
See, it goes green.
But it didn't ask for calibration. Shouldn't have asked for...
If you just...
It should have...
If you just go back to that. Well, see... Yeah.
Yeah. So normally, that's a bug. We don't know why that happened. Normally, what would happen is it would detect that it hasn't been calibrated, and it would say you need to calibrate it.
Yeah. It's pretty up. There we go.
we'll try again. Okay, connecting. There we go. Format. That's what it should do. And it would say start calibration. So you cancel at that point, or you can start calibration. We're going to start calibration. We just hit start calibration, and then the receiver will start moving. You can see there's 4 little red things going, and it basically moves through all of its axes. Now, that prototype rig has hard stops on it. In fact, all of the Pancakes come with hard stops that you can adjust, so you can set where it stops, the end points of the rotational motion. It detects those and then says, right, that's my extent of travel, that's as far as I'm going to move, and it won't move any further. Okay, yeah, sorry. Yeah, and you can see it's now done the, if you go back to the ProMoCo screen, oh, you got picture in picture there. It doesn't matter. So see how two of the ports have gone green? That means it's calibrated those and it's done it successfully. All right, it's just done the pan axis, and now it's just finishing off the slide axis, and it goes to the middle of the extents once it's finished. And it's a little bit louder when it's doing this. So the actual system is, and here it's finishing. Do you want to go to the? Right, there we go. And it's obviously moved into the middle when it's finished. So
it's ready to go.
It's ready to go. Now when you move it, when it gets to the end, it will stop. It will get to the hard point, the hard stops, and it will stop, and then it won't go any further. Like that. So I'm trying to make it go further, and it won't go.
You see it's on 0
You can
degrees.
see it on the, see me trying, and then we go back up the other way, and it can go pretty fast too. So the same with left and right and the slider. Now, if we wanted to make a program,
oh, we should say that the on-screen controls are customizable.
oh yeah,
So
okay.
at the moment,
should we show that?
okay.
All right. Can we just go to the main? Just put ProMoCo back up by itself.
Just create a new
Yep.
setup.
So, do we want to create? No, I'll just go in.
I'll
and
just show you.
We'll just show them.
Yep.
So each axis has got like a little cog setting, and then we've got a bunch of what we call high-level functions, and we can manage the marks. There aren't any. Oh, there are some cues there and some start-end marks because we've already got a program in here. We've got a whole bunch of controller settings. Some of these will be a little bit different in the actual one. Some of those are things that we're experimenting with. And then we've got a little calibrate motor button down the bottom here. If we hit that, it'll recalibrate the motor if you have a problem with it.
Just for that one axis.
Just for that single axis, or you can calibrate all of them, at the same time. And then on the reticle, which is the reticle is the bit that displays the number of degrees or the position, or it displays the measurement that you've got. If you tap on that, it opens up a control panel that gives you some quick controls for that actual axis. You see everything else is blurred out. You can zoom in on the axis. You can zoom out on the axis. You can see all of the marks are appearing because we're zooming out.
And if you zoom out and then move the axis, it'll go a lot faster. If you zoom right in,
oh yeah, sorry.
You'll
right.
have a lot finer control.
So I've just done that on the tilt axis. Now, if I tilt, see how I'm moving a fair old way, but you can see that the reticle's while it's moving fast. Can we just see the actual thing moving? Yeah, that shot. See how slowly it's moving? Because we've zoomed right in, a lot of movement makes it move slowly. Now, if we tap on that and then we zoom in the other direction, it's going to move really fast when we go up and down. See, it's really fast. So you can get very fine control over where you're positioning it by zooming in and zooming out. So if I zoom right in and I want to move it, I want to tweak it up or down just a little tiny bit, I just go down and it's moving
You can barely see it
really,
move.
you can barely see it moving because it's moving so slowly. You've also got this control which increases or decreases the size of the what we call the dead band. So you actually have to move that dot there to the center of this before it actually starts moving. Or you can bring it in if you want less deadband. And then the other bit of control that you've got is the what we call the expo, which is basically how quickly it responds to those moves. So when you get to the middle, if the expo curve is like this, it won't start, you'll have to move almost to the end before it starts going fast. Whereas if you have a flatter expo curve or a completely flat expo curve, it will start moving pretty quickly when you get to the edges. So with the joystick controller, you've got a link button here. So when you hit that, it's now anything that you do here now affects both axes. So I'm zooming sort of to there, which is kind of how I like to have this set up. Now they both are set to the same sort of control level, which sort of is in the middle of everything. The slider reticle is the same. You've got the same controls on the slider reticle. The focus reticle is slightly different. Sorry, the reticle is slightly different because it's a different type of controller, which might as well cover that now.
Yeah, we should talk about that.
So the slider is sorry, the zoom works the same way, but what's actually happening here is when you slide the focus wheel like
and
this,
it's hard. There's nothing happening on screen because
you can just see those white marks.
See the marks.
You can see those white
you
marks
drop a mark
moving.
on the drop a mark.
Drop a mark there.
Wax mark there. Yeah, and then you can see it going up and down.
You can see that mark going up and down. Oh, that's another thing that happens as well. When you get the mark into the reticle, it highlights it.
Which is very good
white.
for focus marks that you want to remember.
Yep. We'll put some haptic feedback in there. It's not in there yet, but it can go, click click when you hit the mark, so that you know.
But the difference between, say, the joystick and the slider and the focus control is that with the joystick and the slider, you're controlling the velocity of the movement. So with ramp up and ramp down. The focus motor is positional. So as you move your finger on the screen, that motor will move to that position.
It's a bit hard to see. Maybe you can see it on this camera here. The side camera, Sam. See when I put my finger on there and I'm moving up and down, you can see it's just moving those marks up and down over the, or you can snap to a mark. I missed it, but you can snap to a mark, move really quickly to the end. What is it at the end? What's going on there? Yeah, and you can zoom in and out to be able to hit marks more effectively. And it's not a velocity controller. It's a positional controller, just like you'd have on a wheel. You're turning a wheel, and it basically is connected to the focus motor. So that's what we've tried to.
And it's hard to get a good feel for this, but the speed in which it reacts is very fast.
Yeah, it's very responsive, and we've worked.
Yes, it took a while.
It's a lot of work gone into making that responsive.
With the focus control, because there's a wide array of lenses out there, there are no marks on the screen when it first launches. But if you have a set of lenses that you use quite a lot, you can put all of your lens marks on the scale and then save that as a configuration. And then when you go to use that rig again, you can just pull up your pre-configured lens and all your lens marks will appear again.
Yeah, so if you change lens, you go in, you pick the lens that you've already put all of your marks in, recall it, all those marks appear. Once it's calibrated, they all appear in the right spot.
Yeah.
as well. So front to back. The only thing that you might need to do is if you've taken the gear and put it on the other side of the motor because you don't have room on to mount it the way you did differently, you have to go into the settings and then tell it it's been flipped over, and then they'll all line up again. So yeah, they're the controls. They're the tweak. That's the tweaking that you can do with the controls. At the bottom there, you can see focus, and then these two little arrows, and then a C. That's what we call the quick mark. So this M, I'm going to tap this M, and you can see a mark appears on the scale. That's basically what we call a wax mark. So if you're used to pulling focus and getting your wax pencil and putting a wax mark on your focus dial, well, that's where I need to be. That's kind of the that's analogous to that. That's a wax mark. You can then change the name of that mark if you want. The other types of marks are this red mark here and this green mark. They're the start and end marks for the program, and then the final one there is the CQ mark, which is a kind of a program type, I suppose.
Yeah,
it's kind of a program type, which it's a cue. So when you hit a button, when you hit the cue button, it will go to that position based on parameters that you set up, how fast, ramping, and all that sort of stuff. But what you do here is you can adjust and put a single mark on one axis here. There's another way of putting marks on which puts it across all axes. So if you're doing a cue across all axes, you've got a quick button that just allows you to drop a mark across all, and you can go in, of course, and edit the cue as well. Edit its position.
So if you go out of there and go into the main queue management button,
that one.
Yeah, you can grab that queue that you just dropped.
That one there.
I think so.
Yeah, that one. Yeah, there you can see they're the parameters that you've got around a queue. You can ramp up, you can ramp down. You've got ramping up and ramping down, which you can adjust. You can link them together, and then they go together. And then you can adjust the speed of that queue. So down here, 5% is very, very slow, 100% is very, very fast. We put a percentage there as well because it's the percentage of the maximum velocity that it can move from where it is to where it needs to be. Because if you're all the way at one end of the axis and you need to get all the way to the other end, if you put an actual speed there, it may not be able to achieve that speed, and that's problematic. So that's why we've made these percentages rather than actual times, because they're times in the program.
And it's important to know that you can have a motion program with some of the axes. Let's say you've got a 4-axis rig like that one, and you've programmed the slide, the tilt, and the pan to move from start to end, but the focus motor is not part of the program, but you can still hit a cue with that focus motor while the program's running.
Yeah. Or if you wanted to, you could pull focus manually. So you could have the rig moving from left to right as just as a dolly shot, and you've got two people, one in the foreground, one in the background, and you want to focus from one to the other while they're talking, you just pull focus manually between them while the program's running. If they're not moving around too much and you don't have, very shallow depth of field, you could use cues. So you could cue from one cue to the other, cue from one cue to the other. If you're going cinematic and you've got very shallow depth of field, then pulling focus manually is obviously going to be better in that scenario. So at the moment we've actually got a program on there, but let's just redo a program, so that you can see it. So what I'm going to do is we'll just do the full length of the slide. So I'm going to slide all the way to one end, like that, and then I'm going to turn the camera in a little bit. This is showing the framing, and we're going to pan down a little bit, maybe back up a little bit. Well, let's make that Lumix camera the central part of the frame. So I'm going to move that into the center of the frame. Now I'm going to focus it. Okay, so now we've basically set all 4 axes. We've framed the shot roughly where we want it. Let's just move it over a little bit more. Oh, wrong way, other way. Oh, that's something else, actually. I'll just quickly show that. I've just moved the joystick in the opposite direction to what I thought it wanted to be moved in. And I've gone, no, that's not right. I want to change the direction that the pan goes in. I just tap this reverse button, and now when I go this way, the pan goes that way. And when I go the other way, the pan goes in the other direction. So you can flip it just depending on how and where you feel that that should be. I'm going to move that guy down a little bit. Okay, so that's framed. That's kind of focused. Hang on, let's just muck about with the focus a little bit. Kind of focused. Now what we're going to do is go to, in the center, let's get the big one up, Sam, so we can see. This is a, we go to the center. Now we've got like a mark panel here, or these are the mark all. And down the bottom there you can see add queue. That would add a queue in that position across all axes. But at the top we've got mark starts and mark ends with the little red arrow and the little green arrow. If I hit mark starts, you'll notice that all of the red arrows on all of the axes will now jump to where our current position. And what we've just done is we've said that's the start position for all of the axes.
Yeah.
If we now go, we're going to go to the other end. Right, all the way across. We're going to. Oh, I don't want to change my my tilt. I want my tilt to stay in the same spot. So what we can do is lock the axis. So the axis is now locked, and you can see there are a couple of little. Oh yes, yeah, that's right. They're linked at the moment, so we need to unlink them. You can see you've got a little P mark, a little
padlock,
on the reticle as well. So that just gives you an indication that it's locked or that it's running the program. Now the P, if the P's on, when you hit go for the program, it'll use that axis in the program. If the P is off, it won't use that axis in the program. And that just gives you the ability to turn that axis on and off in the program. Anyway, we want to lock that one. We've locked it. Now we're going to pan the axis across. But you see if I go up and down now, it's locked. It won't move up and down. It'll only move left and right.
Sorry, show the up and down again.
So we're going to show the up and down again. So see, I'm going up and down and it's not moving, but if I go left and right, it does move. So I'm going to move the camera into the center again, like this. Now the camera's looking there. Let's adjust the focus again. So the focus has probably changed a little bit. Yeah, there we go. All right. So now we hit mark ends. We've just dropped 2 marks down there, and that's it. That's the program. So if up the top here we've got two buttons, the second row of large buttons at the top. We've got this one here, which is the red button. That's go to the start, and then the rig's going to the start, and then we've got the other button, which is go to the end, and now the rig's going to the end. So you can check your start and your end points. We're going to go back to the beginning now. I'm going to hit play. Let's go to the pro.
Just before you do,
yeah,
clear out all those cues and marks. There's so
okay.
many.
Yeah.
So if you go to cue panel,
yeah,
and then there is a
clear all down the bottom.
Yeah. Get rid of all those. All right, and we don't have so much distraction.
Yeah, we've got the wax marks, but that's fine.
All right.
Okay, so yeah, we just cleared all of the cue marks that were there from previously. So we're just going to go to the program panel now. So this is the actual program. From the top down, we've got we've got what we call the shuttle control. So we've got start and end and play. So you can go to the beginning of the program, the end of the program, and you can run the program from this screen if you're testing things. You've got a start delay. If you tap on that, it goes to, setting that delay. So if we set the start delay to 1 second, we now have a start delay of 1 second. Next to that, we've got pre-roll. Beyond that, we've got motion duration, and at the very end, we've got post-roll. And they work by, the start delay is just how many seconds it waits before it starts a program. The pre-roll is the amount of time it waits before it starts moving. But if you're triggering the camera at this point, it triggers at the beginning of the pre-roll. So you can just have some no motion recording before it starts moving. Motion duration is the length that the length of time that it moves for, and post-roll is the length of time that it leaves the camera on before it stops the camera. We'll just set that back to 0 because it's not going to make any difference to us. We can set the amount of ramp, the ramp time, which is basically your ease in and ease out, and it's in seconds. So say we wanted a 3-second ease in and ease out, we do that. If we wanted to do a different ease in and out for the beginning and the end, we could just unlink them and do, like that. But let's make it ramp in and out. And then the motion duration, of course, is however many seconds we want that motion to run for. So yeah, that's basically a program. And then here we've got a whole bunch of settings, which I'll get to in a second. Let's just run that program. Let's go back to the main screen and hit play. And it'll start just moving over 20 seconds. It does that ramp up and that ramp down. And it should be keeping the camera in focus the whole time because we've set the focus as well. Yay. Whoops. Yay. And away it goes. It's set to multiple repeats at the moment, so it'll just keep going left and right basically until we hit stop. Now, I'll go back to the program panel and take us to the settings part of this. So it's the little cog on the top right. Now, on the left-hand side, we've got common settings, and on the right-hand side, we've got the video motion program. The left-hand side, we set the frame rate, which should be set to 25 frames. This really becomes important if you're trying to do frame syncing. So as long as that's set to the frame rate that your ultimate part's going to be.
Is that camera recording now?
No. Oh, no, it might be. Yeah, no, it is. Yeah, it is. It's set to trigger. I don't think there's a card in there, so it won't be recording. Anyway. Below that, you've got the name of the program that you're currently running. This one's called Plate 02x1 because we were working on something before. You've got a save program, a load save program, and a share program button, which are all pretty self-explanatory. Whoops, wrong button. If we go load, we've got a bunch of programs that we've saved previously, or we can save this program as a new name. Now on the right-hand side, we've got.
Do you want to talk about the share? It's kind of a cool feature.
Yeah. So I mean, if two people had the same rig, say you had a tilt, pan, and slide rig, and you wanted to do some work in the studio and comp that with some external motion that you've filmed outside. So you've climbed to the top of Mount Everest with one of these, you've set it up, you've done this awesome, tilt, pan, slide across, the Himalayas with the clouds rolling, maybe a time-lapse with the clouds rolling at the bottom.
That video is coming next week, I think.
Yeah, you fund
from our Himalayan trip.
Yep. So after Kickstarter's funded, we're going to the Himalayas with all the money. No, kidding. We would, you could then share that program with the people in the studio. So you upload it, and then as long as they've got the same rig and your end stops are set to the same position. Oh, and incidentally, all the end stops have little markers on them, so you can actually set them very accurately on the pancakes. So you can actually do this as long as you've got where those stops are on your pancake. You could share that data with whoever's working in the studio and set it up identically. You'd share that program with them, they'd load that program and that rig configuration as well. That's important. It has to have the same rig configuration. And then you could do the second part of that composite shot in the studio on a separate rig. So there's no need to then take that rig and carry it back to the studio and then, you know, do your second set of shooting in the studio with the same rig. You're able to recreate that motion on another Axiiio rig. Also, we're going to have a web portal called Axiiio Hub, where you can put all of this stuff and also share the actual film itself. So, you know, you would upload, say you're working in the Himalayas and your studio's in London, you would upload your film data and all of the metadata for that particular motion, for that particular move, and then the person in London could take that metadata, go into the studio, film the talent, and then comp that together in the studio while you're climbing down the mountain.
Getting over frostbite.
And getting over the frostbite and all the other stuff. So that'll be in the share, but that's another whole... The Axiiio Hub is another whole thing that we have to think about. Not coming anytime soon. So we go back to the different types. On the right-hand side, we've got different types of program. We've got a video motion, we've got time-lapse, and we've got stop motion. Right now we're running video motion, and it's really simple. You set your start and end frame, you hit play, and away you go. The only things that you can really set there is whether the camera starts at the start and triggers at the end, and the number of cycles that the camera's doing. So it's ping-ponging now, it's set to 100 cycles, so it's going to go 100 times. So it's going to go from the beginning to the end, that's 1, from the end back to the beginning, that's 2, from the beginning to the end, that's 3, from the end back to the beginning, that's 4, and it'll do that 100 times.
96 bottles of beer on the wall.
Yeah, exactly. Oh, and one other thing that we thought was very important, if you can just show the main screen again, Sam. I've just turned off the program. That middle panel there shows you the total time that this should take, the remaining time, the total number of cycles that you would be doing, and the remaining cycles that you have in the software. So if you go away, and you can do this, walk away from the program, come back an hour later to see how far through your time-lapse you've gone, you connect to the app, it will pop this screen up, refresh it very quickly, within half a second, it'll refresh it, and you'll see how much time you've got remaining.
Are you brave enough to try that
program
right now?
Yeah, sure. Absolutely. So I'm going to turn Wi-Fi off.
Ooh, this is going to be
Wi-Fi's
scary.
off, so it's basically disconnected. Now, Sam,
But it's still running.
turn it back to the program. In fact, and now I'm going to shut the program down. Donk, gone. We've shut the program down.
The rig is still going.
And the rig is still going. Let's start ProMoCo again. Oh, hang on. Let's turn Wi-Fi back on first.
We need some Wi-Fi.
Let's turn Wi-Fi back on first.
All right.
Now, you'll notice it's connected to a different network. It's connected to Haxiiio, I've guessed. And I'm just going to leave it like that. I'm not even going to bother changing it back. So if you were working in your studio and your phone or mobile device connects back up to the standard mobile network that you normally connect to, it wouldn't connect to ProMoCo. But it asks you this question at the beginning, do you want to join it? You go yes. Hopefully this works. And it's reconnected, and if we go to the there you go, it shows you the total time.
It worked.
How many number of cycles you've done. And we've worked really...
And the program's still running.
We sound surprised, but that bit's actually been in there for a long time because it's something that happens on set all the time. You walk off, you've had lunch, you walk off, you go to the, you take your phone with you, you go wherever, or it switches off. You switch it off to save battery and it disconnects, and then you try to reconnect it and it just doesn't work. You don't have to stop anything. Your workflow doesn't have to stop. That shot doesn't have to stop. If you're not filming, if you're not actually running a program, it will do the same thing. It'll just not be running a program when it reconnects. So it's really easy to reconnect when you've come back. So let's just talk about the different programs again. Video motion, number of cycles, camera triggering, we've covered all that. We've got Time-Lapse program. I'm just going to use mobile data there. It's got a Time-Lapse program. So basically what happens is the program screen, say you want a 20-second clip. Let's go back to the program screen. Say you want a 20-second clip. You want 3 seconds of ramp at the beginning, 3 seconds of ramp at the end, total duration to be 20 seconds. When you've finished your time lapse, that is the duration that the frames when they're assembled will be, and the ramping will be 3 seconds, the ease in will be 3 seconds, the ease out will be 3 seconds. So basically, all you now need to do is tell it how long you want it to run for. So say you're capturing a sunset and you want 25 or 30 minutes of capture time, you would just set that to, say, 25 minutes. 25 minutes, and that's all you need to do. That's all you need to do. So what will happen is it will go click, it'll move a tiny little bit, it'll go click, it'll move a tiny little bit again, it'll go click, 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 click. For 25 minutes, it'll take a frame right where the frame that if you were filming video motion would be, all the way through to the end. So when it comes time to comping, if you've done a video motion pass and then you've done a time-lapse pass, those two will lock together at the end. So you'll be able to comp them, and they'll be, when you comp them, you'll be able to overlay them, and if you've got any sort of background information or background in your shot, they will all be moving at the same speed at the same time.
Frame accurate.
Frame
is
accurate.
how you put it on the video.
The next bit on the screen is the move ramp, and that's basically when it does, because it's doing move, shoot, move, it takes a photo, it moves, and it takes another photo. The ramp there basically controls how fast it ramps up and ramps down when it does that tiny little move. It calculates the total number of frames, it calculates the time between frames.
Why would you need to adjust the move ramp?
If they're really big jumps, then you want to have a slightly higher time than if it's if it's shorter. I've played around with automating that, but in some instances you want to make it really short so you can get more frames in. So it gives you a little bit more control to have that. If you're doing your standard ones, I mean, 0.6, 0.7 seconds is all it needs to be, and it's nice and smooth, and it ramps up and ramps down and gets you to where you need to be. Because you've got to remember, it's moving only a very small amount each time. So it calculates the total number of frames, the time between frames. Then you've got some camera triggering down the bottom, which hasn't been finished yet, but essentially you can, the camera can control the exposure, so the length of time that the shutter's open. So you would set the shutter speed on the camera. If you go bulb control, the exposure time is now, you set your camera to bulb mode, of course, and then the shutter time, the exposure time is set by the ProMoCo app. So it will trigger the shutter, leave it open for the exposure time that you've got there, and then it will then switch it off when that timer has expired. And then bulb ramping is basically, it doesn't have all of the options down the bottom yet in the app, but bulb ramping is basically if you're doing a sunset, you can ramp the exposure time or the shutter opening and closing time over a period of time. So, and here you'd have a start time and an end time for your triggering. So it would start at, say, 3 seconds, and it would end with the shutter being open for 6 or 7 seconds or something along those lines. And then over time it would slowly but surely increase the amount of time that the exposure is on for. The next program is stop motion, and it's essentially the same as time-lapse, except at the end of each picture it stops and waits for some input, and you can rewind back to the previous frame, you can go back to the next frame, and if you were to connect your camera up to something like Dragonframe and do all of the image capturing in Dragonframe, you could then have your computer sitting there and go flick through some onion skins. It's fairly straightforward for us to make this Dragonframe compatible as well, and it's something that's on our list. It's something that
I think it's something that a lot of people will want.
It's been really requested, so it kind of went from, you know, middle of the road up to the top. The other thing is Dragonframe can output multiple keyframe motion data to axiiio, so it might be a way that you can do multiple keyframe motion kind of cheating using it via Dragonframe. So that's something that we can, it's just really, I think it's just going to be a software thing. We might need to build a little bridge that plugs into the USB port of the computer so that that data can be output to axiiio wirelessly. I think that's it for program. Nobody had any questions about programs? No?
There was a question about, is there a limit to what sort of camera I can connect? And can I connect a video camera? You can get it in any sort of camera.
Any camera.
It'll be the weight that's
the weight will be the weight that will be the issue. We've got multiple trigger leads. USB support really was going to depend a lot on the manufacturer, and we don't have a list of cameras that will be supported by USB yet. There's a little bit of work to do in down that avenue before we can definitively say it works with camera A, camera B, camera C. Because it's got a serial output. Remember when we were talking about the receiver, we talked about the serial port output. A lot of professional cameras, Red, Blackmagic, ARRI, use serial RS424 or 232 in some circumstances to control their cameras. We can have an interface to talk to them as well. And then you can do things like adjust aperture, adjust ISO and color and white balance and all that sort of stuff on the fly from the ProMoCo app. Again, a feature that we will add later on.
And something else we're going to add, because the device connects to the receiver via Wi-Fi, it means that we still have Bluetooth on the device, and we can add like game controller compatibility. So we can, if you want, you have a little keypad game controller, like a PlayStation controller, and use that for moving your camera around.
Yeah, we've got a few ideas about how to integrate that as well. So yeah, keep your eyes peeled. I guess that's a good place to show actually the hardware controller.
Oh yeah, right.
So earlier on we talked about Wi-Fi and the fact that this connects via Wi-Fi. Should we show the? Yeah, we'll show that one. Yeah,
that one.
Yeah, that one.
All right.
So in some of the films that we've done, you might have seen this little guy in the films. This is our prototype hardware controller. So we have a focus wheel over here, and we have a handle on this side that you can hang on to. I'm just going to turn it onto the other camera over here. Yeah, focus wheel. And then on this side, we've got a handle, wooden handle. It's got a joystick here, a little tiny joystick. And then on the back, we've got like a thumb wheel. This is our prototype hardware controller for people who want a more professional workflow. And it's basically a modular component system using NATO rail. We may use, at the moment we've got a NATO rail on one side, and then on the other side we've got a rosette. We're leaning more towards NATO rail, but we may have rosette. We may have one of each, and just make the rosette detachable so you can put it on the other side, because that means you can be right-handed or left-handed control. So it's ambidextrous. You don't have to worry about, buying a left-handed or a right-handed version. It does both. And we can mix and match these around as well, depending on what type of controller you want to run with it. The software we're thinking will be flexible enough that you can assign these to really what you can assign the wheel to whatever you want. This is actually a DJI controller that we're using as a dummy. We have built one, but this one's that's in bits somewhere else. We couldn't really show it to you today. But yeah, it looks a little bit like this. No, it's not identical, obviously. Similar, but not the same. Same, but different. Yeah, so these would plug into this central box, and this central box also has, so it's obviously got a phone holder on the front, and then on the back we've got a little, I think these are Sony NP battery holder. It's got some power outputs, and then these holes here that don't have any plugs in them would connect into whatever accessories you put on the outside. There's a NATO rail on the top, so you can put things like monitor mounts, and normally we put the video receiver here so that we can just plug straight into the monitor. And then you've got an all-in handheld professional controller for the axiiio system. So if you've connected yourself up to a gimbal, and you're doing second operator, and you've got a video transceiver on the gimbal, this is all you need to control the gimbal, control focus and control all of the other parameters that you want to with the camera, pan, tilt, iris or zoom or whatever, however you want to set that up, will be possible to do. It may not seem like it, but we've actually got a lot of experience with building these.
Okay.
Should we show some of those? This is like version 4 of hardware controllers that we've been.
These two here.
Yeah, maybe grab the first one, the very first one. So this is kind of in
for
bits.
bludgeoning.
This is our beating device. It used to have a wheel on the front. There, like a whole controller. The idea was that you held it in your hand like this, and you pulled focus there. It's got a bunch of buttons down it. These all used to light up, pretty lights. I had a light chaser in there. You can see it's all very prototypey in the back. But this is the very first 2-axis controller that we built, and this didn't use Wi-Fi. It was just an industrial radio telemetry, which is much more reliable than Wi-Fi or Bluetooth. And a lot of people have asked about that. Can it do it? Well, we have done it in the past. We went for Wi-Fi because it's less expensive, far less expensive, and we feel like it is reliable enough for many situations that you're going to be in. Not all of them, but for that, we have another option for people who want to go fully professional. So the second one,
I just have it here,
is this guy, which is again a full hardware controller solution. We've got a joystick here. We've got a slider there.
It's actually a screen on the front there.
I might go here so you can see it. The antenna screws in there. It's got like a little lit power button on the top. Battery goes in here. There's your joystick. You've got a slider here for iris control and focus. And then it's got a screen in the middle. Hardware controller, everything's built into one. It had a couple of, cue buttons, sort of quick cue buttons up the top that you could assign to various cues. Again, this used an industrial radio modem, completely separate, didn't require an app. There was no iOS or Android involved. And then the question is, why do we go to an app?
Well,
and it's, I think Andrew will answer this as well, but it's so much more flexible when we go to an operating system like iOS or Android. I think the difference, and a lot of the app anger, and I don't want to use another app, what happens if my phone rings, has a lot to do with the fact that people haven't thought the software through from beginning to end, and all of the things that can get in the way of workflow. I'm not saying that we've done it, but we've worked really hard to try and remove all of those issues. So I'll just come back to this guy, which is our latest prototype. You would put your phone on here. And there's two versions. One that uses Wi-Fi as per normal, and it connects via Bluetooth to this box, and the outputs from this and this go through your mobile device to the axiiio receiver. And then there's a professional version of this which has its own radio modem built into it, which has nothing to do with Wi-Fi. There are multiple bands, multiple distances that you can travel, a 900 megahertz radio set, which the bands are slightly different in Europe, US and Australia, but you know, you just pick which region you're in and choose that radio. They sort of have 3 kilometre line of sight, so you could use it with a drone or, you know, anything like that. But now what's happening is the hardware controller is doing all of the control stuff directly to axiiio, and the app is acting more like a database repository and display with extra control, because all of your communications are going through through this. And that version would probably have a couple of buttons for doing different things, just in case your app crashed when you were in the middle of something and you absolutely needed to run a queue or something like that. You probably have some hot buttons that you could run queues
That's
on.
the other reason why people hate apps. They crash right in the middle of your shot.
Yeah.
But ours doesn't.
No. Surprisingly, it doesn't crash much. I say
Why surprisingly?
I say surprisingly because he's the developer. Just
Well,
jokes.
I mean,
just jokes.
I think that's the number one reason
Sorry, I'll
is
get that out of your way.
everyone has a device these days,
Yeah.
and they're pretty good quality. The screens are good quality. The touch screens are excellent, and it's completely flexible. What we can put on there. They have connectivity. They have other sensors like motion sensors in the devices. All of these things we can just utilize. We don't have to actually design anything, you know, new to do that.
Yeah. That was the
just
biggest
seemed
problem with this, is every time you wanted to update the firmware for that screen, it was horrible process to do, and difficult for you as an end user to update the firmware in this. Not simple, not easy, hard, and expensive. Really expensive for us to produce. Really expensive for us to keep it maintained.
So
Yeah.
for us, starting out, it couldn't be easier to have a kit that you assemble and then you get a free app on your device and you connect to it.
Yep.
And you rock in and roll it.
Yeah, it's free as well. That was the question on
Yeah.
Kickstarter.
Yeah.
How much will the app cost?
It's free.
We just went, well, it's free, and we've been talking about it being free for so long. We didn't even write it down. Yeah.
Everyone who's used the app has not had any issues.
Yeah.
Oh, really?
Yeah. Well, I never did.
Yeah,
It
right.
worked
Yeah.
perfectly for me.
Yeah.
So Sam, who's driving the bus today and switching everything for us, has used it, and he's just saying he hasn't had any issues. We haven't paid him to say that.
Or at all.
he just said or at all. Yeah. So it's
All right. Moving on.
moving on.
Getting to
Should we
drama.
get into some of the other prototypes that
Yeah, the good
we're
stuff.
working on? So,
So, this is a reward if you've actually stuck with us to the on this 2-hour live stream.
yeah, we weren't expecting to go this
Some
long.
some fun gear. What do you want to start with? This fun thing?
Why don't we start with the
The slider?
with
That
that,
one?
with that shark slider,
All right.
just so we can just show a kit that we're.
All right.
So this is another slider. It looks very much like the other one, but this is not our little slider. This is made by iFortage. This is a fairly popular slider, which is fairly cool.
So there was just a question about the app. Will you eventually manage to copy the phone movement to match the actual camera motion?
I
Maybe
think
he was asking about gyro.
yeah, because I did mention that they have those gyroscopic sensors, and We have actually talked about that.
Yeah.
Using all the 3 degrees of app motion that you've got to translate that to camera motion. So yeah, it's something we've talked about.
We haven't experimented.
We haven't
with
tried it, but it's something we want to add.
I mean,
if it works.
Once we've launched the app on the store, we'll probably have a feature request.
Oh yeah.
We will have a feature request
Yeah.
spot. So that's something if enough people say, hey, we'd like to have a gyro controlled phone. I think that's what the question that we're answering. A gyro controlled phone, then it will work. If that's the question, I'm not sure we've answered it, but anyway. Okay, so back to this slider. This is commercially available off the shelf iFootage shark slider. The good thing about these is you can extend them in both directions, so they don't necessarily need to be that short. They can be longer. These are pretty good. They're pretty stable. They're certainly more stable than the one that we're currently using, but they're a lot more expensive. They're probably more than double the cost just for the slider. But we will have all of the STL files to make all of these components available on our website. We'll have all of the STL files. Plus, we will make available 3D printed parts as well, so you can order 3D printed parts if you don't have a printer. And depending on how many requests we get for a particular slider, so I would say this one's a very popular slider, so we would do this with this one. We'd make a kit up for it. So, you could go into, when you buy a starter kit, you could select a kit for the iFootage slider to attach a pancake and the belt to make it run with our other components. So that's kind of, I guess, what are we calling that? We're calling that the DIY support. And the DIY support's kind of in 2 levels. One where we make a kit to fit a bit of equipment like this, so you can bring it into the axiiio ecosystem, and the other one is we will provide the engineering data for you to be able to make this out of plastic if you want to on your 3D printer. I think we'll also have a spot on the website as part of the Haxiiio hub that enables users to share their attachment methods and STL files and instructions on how to attach that. So if you've got, a Kessler slider or whatever other brand XYZ, you can share that data with other people so that they can attach the pancake and the motor to it to make it work.
Next.
Clear as mud. That's kind of a level of support that we want. It's us. We're doing engineering. We're actively doing engineering on different sliders to make sure that we can attach it to it, but also the community. Take our designs, modify them, make them better, feed it back to us, and if it's a good idea and it makes sense, then we'll, maybe iterate those components to.
What is this then?
To include it. Aha! So the slider that we showed earlier, the tilt pan slide, the one that's currently running in the background, is what we call the Nano slider. So it's small, it's lightweight, it's made for small cameras, micro 4/3. You probably could put something like this on there, although this is with a big lens, this is starting to get unstable on a small slider like that because it just doesn't have the width like this. It's got 2 rods that are about that far apart. As you can see, this one is, fairly wide across here. It's also got 3 rods, which makes it much more rigid than your standard 2 rod sliders. This is obviously a 3D printed prototype. It's not a metal one yet. We are working on getting some metal ones and testing them.
Brackets are printed.
The brackets are printed, yeah. These brackets are printed. And this is a system. So this is a rail system as opposed to just a slider that you buy and it's a fixed length. It's extendable. So we have these rods, which are like this. This attachment method may be the one we use. We're not 100% certain, remembering that this is a prototype. So you can extend it like this. And you can extend it again, and you can extend it again, and you can extend it again, and again and again. There's no practical limit to the length of this slider because we can put, and it's plastic, so it'll spin and it's not very rigid at the moment. But there's no practical limit to the length that we can make this slider because we can just put, we can just keep extending it. Sorry, I'll just get that in the right spot. Open that up.
How will I carry all my cool axiiio gear? Will you have a custom designed axiiio specific carry bag?
Oh man, I love bags.
It's one of my dreams. Did they hear that question in the audio?
Somebody asked, will they have a cool carry bag to put all their axiiio equipment in? And I said, oh, I'd love to design a bag. It's been my dream to design a bag. At the moment, we haven't even thought about a bag. It's all going to come in plain.
I mean, you've got your own bags, but you've got cases with laser cut mold foam inserts.
Yeah, I mean, I've built cases for all of this, but we don't have a commercial solution. Oh, that said, we do have some hard case suppliers for hard cases. So yeah, at some point we'll have hard cases. Soft bags we haven't really looked at yet. It just depends on what people want. Like if you're on sets and you're chucking your gear in and out of trucks or utility vehicles, or you're strapping it to the back of a motorbike and you're driving up a hill to do a shot, you want hard cases, you don't want soft bags. And we're not sure what the take up between people who are hiking, on foot, hoofing it, don't want hard cases, to people who are, chucking it in the back of the ute sort of deal. So we'll probably offer both at some point, but at this stage, we just need to get the hardware out there. This will all come in nice recycled, plain brown packaging. We're not going to be doing any of that Apple fancy
packaging. It'll be part
stuff.
of the Haxiiio fashion label, I think.
But it'll look nice, and it won't be horrible.
T-shirts.
And it'll be reusable too. So if you want to put your gear back into those boxes, you can and carry it around. But at the moment, we don't have any firm plans for bags or that sort of accessories. Apart from the hard cases, which we will probably offer fairly quickly.
Anyway,
yeah. So yeah, we extend it, and then we can extend it again, and then we can extend it again, and it's very, very rigid. That's the point, and it's very wide.
At each one of these things, brackets, you've got a mounting potential.
Yeah, you've got support and mounting potential.
Make it really rigid.
So one of the things that we're going to do in here, and we may be working with somebody that I can't talk about yet to do this, is mount these. We've got some lighting rigging in here, is mount these upside down up there. So we've got a track in the roof which we will hang a tilt pan from on a Z-axis, so it can go like this in the studio, just as an example to show what you can do, what you could do with the hardware.
If you wanted to show that, you could point the axiiio cam up there if you think it's worthwhile.
Yeah, maybe. I just want to talk about the rosettes and this mounting option. So I'm just going to go to this camera, Sam, if we can. This is the holder, and this will obviously be out of 6000 series aluminium most likely, so it's nice and rigid. It's very light because it's just a frame really. It's quick. It's all quick release, so you slide in and you just lock in with the quick release levers, and it will have rosettes, most likely have rosettes, which you can put legs on. So, you know, this is sitting on the table. You could have a leg down here, a leg down there. There'll be multiple height adjustable so that as you add lengths on uneven ground, you can level the whole thing to turn it into a dolly that can take a nice heavy camera like a Red or an ARRI or any of those other camera systems. Now, I don't have a plate that goes on top to show you, but it's very wide. I mean, I'm hard pressed to think of sliders that'll be in this price point that will have the width and weight carrying capacity that this thing has and be as, you know, simple and easy to set up as this. The plate that sits on top of it sits on the outs. It's got some nice cool roller technology, so it sits on the outside, so it can slide in these gaps, and it will also have some leveling components in it, so that if you want to put it vertically, you can mount your camera. You don't have to get another plate and do anything. It will just handle. It will be able to handle doing vertical shots or inclined shots. And the mechanism for doing that is not difficult at all to set up. Now, that plate will come in two versions, and the first one is what we're calling the cinema slider version, and that basically takes the standard motor that we've shown you today. You put that on, away you go. I think it's how many millimeters per second? 300 millimeters?
No, it's 220.
220 millimeters per second,
Yep.
Maximum speed. So
horizontally,
so about that fast, maximum speed, which is, well, it's a lot faster than most of the other ones for a start. But if you're doing high speed work and you want to set up a really long dolly and you want to put a heavy camera on here and you want to make it go really fast, we're going to also have the cinema speed version, which has a different motor on it. It still plugs into the receiver and it still works in exactly the same way, but that motor is built into that plate and you can engage it or disengage it. So if you want to use it just as a slider, you can. And that will make it move a lot faster. How fast? Dangerously fast. And that's all we can really say because we haven't tested its maximum velocities yet. We've only got theoretical, and I don't really want to talk about theoretical stuff until we've actually tested one.
Yes.
But it's going to go fast. And in fact, we've been discussing whether we need to actually have safety systems as part of it because it can go fast enough to hurt somebody, and we are actually concerned that it might be going too fast.
It's not a product feature.
It's not a product feature, but we might have to build some safety stuff into it so that you can't get in the way of it when it's going.
Next.
All right, so how about some hacked rigs?
All right.
Do you want to do
this fella?
This guy? Yeah. And here's what we prepared earlier.
It's that guy.
So this is a focus stacking rig that we built for them what wants to do close-up work, precise close-up work. Take a picture, move, take another picture, move, take another picture with a macro lens zoomed right in. If you do macro work, you know that you have a very shallow depth of field, and then you can stack all of those pictures once you've taken all of them in something like Photoshop. And there are some focus stacking software that you can just get that does that a bit better than Photoshop as well. But if you're into that, you could build a focus stacking rig. Now this is just, I'm going to go to the other camera, Sam. This is just a standard, it's an ISO standard extrusion. It's a twin extrusion. It's got a linear screw in it, and it's got a couple of bearings at the end, and it's got this plate. I bought it pre-assembled with the screw and everything and the plate. I think it was about $60 US, $50 US, something like that. And then we printed up some ends, some 3D parts for the two ends. We put one of our rod holders on it so that we can mount a battery on the end. We printed up a little holder so that we can put a QR plate on there and mount it on a tripod. We put one of our clamps on there, and also we printed a little, don't know if you can see it in there, an interface, an interface plate, so it screws from there onto there. I think all up, this cost, not including the axiiio components, well, just the price of the extrusion, it was like $60. Because
and plus a starter kit.
Plus a starter kit, yeah. We mounted this guy on the end, and that turns the screw and moves this guy. And it's really, really quite simple. We'll be putting the plans for this up on the website, and we'll have some links to the extrusions where we bought them, which ones will work, and just some general information on how to make this work properly. Because it was
just to complete the picture, that's a standard Pancake.
Yeah.
And you just slide a motor onto there, and then you have a receiver. The camera's on here, and then you can turn this fella with the motor.
Yeah. There's a few fasteners that you need.
Yeah.
Yeah, we can put all of those. We will be putting all of those on the website, as well as the stereolithogram files for these end plates. That, that's one example of something that you can just build. If you have the time and energy to do it, and again, if something like that's popular, then we can supply that as a kit as well. But we have to pick things that are going to be popular for us to put the engineering time into making it available as a manufactured set of components. We got a pan. Can you just pass us the Capstan one? So we've actually got a video on this on the website, and did we put it on the Kickstarter campaign?
No, it's on the YouTube channel.
It's on the YouTube channel.
This was a stretch goal on the Kickstarter campaign. That clamp.
This clamp was the stretch goal. Now, along with the just going to this cam, Sam. Along with the keyholes, along with the 1/4-20 and the 3/8 standard mounting holes, the Pancakes also have our keyhole clamping parts to it as well. Now this enables you to stack pancakes up. So you could stack pancakes like this, but it also enables you to quick release pancakes to objects like this with the clamp. And so this little lever on the side here, we just put it on the keyhole clamp, we slide it up, and then we lock that down, and then that's nice and firmly and rigidly held. Oh, it's plastic, so it's a plastic prototype, so it's not holding as well as a metal one will, but yeah, you tighten that up, and then that sits there nice and rigid, and that's a nice quick release system. So if you've got multiple, I'll just give you a closer view of it. If you've got a Pancake and you want to keep reusing it on different projects or on different things, that quick release system enables you to do it. Now this one, obviously, we run a cable, a line through here, we wrap it around 3 times, we come out there, we put that down on the bench top or on the ground or on a reasonably smooth surface. We mounted a ball head here. Not sure if we've got one of our ones. Yeah, we've got that one there. We mounted a ball head on here, and then one of our axiiio ball heads, and then put a camera on there, and then we have a dolly. So if you're interested in seeing how we did that, we have a video on our YouTube channel.
It's there. It's
Skateboard.
delivering you a beer.
Skateboard, and yeah, it brings us a beer. Win-win.
Okay.
Yeah, this is one of the ball heads that we are probably going to be offering. This is the smaller version. This is the smaller version of the ball head. We have a larger 54mm ball as well. They probably won't have this top panning bit, but yeah, these are really cool, and some tripods as well that we've managed to source. Yeah,
All right.
Do we want to show that?
Oh,
It's not assembled though, it's in bits. So we can't really show that. Sorry.
we do have the part 1 video on the channel
Yeah.
showing the Sentry gun.
Yeah. So one of the things that we do is Haxiiio on our YouTube channel. And Haxiiio is where we get to be professional idiots because we're good at that. And we just come up with stupid ideas that use axiiio motion components, and we make stuff. And one of the things that we've been making and working on is a Nerf sentry gun, which we can't show you because it's currently disassembled, because we're filming the next part of the series, which will be out at some point in the future.
Hopefully it won't be as violent as the last one.
Oh, I'm sure it will be. You should watch it though, because it's pretty funny. It's pretty funny. Not for Andrew, but you know. Nerf sentry gun.
Okay.
Is that it?
We're at the end.
We're at the end. We've
We
explained
made it.
Don't know if there are any other questions, or did we answer all of them?
There's the list that you've answered in text form. I don't know if you want to answer them on video.
Is it long enough? Have we gone on for long enough?
Yeah.
Yeah, some would say.
Yeah.
Half hours is long enough.
2.5.
Yeah.
Wow, we thought we'd be an hour.
On the Kickstarter page, and if you don't know where that is, just go to axiiio.com, which is 3 eyes.
AXIII.
And
.com.
on the Kickstarter page, there is the FAQ, which has about 11 or 12 questions that we've gotten from other people that we've answered there. That's useful if you want that info.
We've been sitting between 8 and 10 people. Do you want to just give a quick, like, thanks for watching?
Oh yeah, wow, 10 people. I thought we'd get maybe half of a person.
Yeah.
Thanks.
I'm amazed so anyone turned up.
Yeah,
Thanks, guys.
wow. That's awesome. Thanks for sticking with it. We hope that's been some useful information. We probably should have done this at the beginning of the campaign.
Yeah. There were mistakes made.
We've made a few.
We've
boo-boos,
learned our lesson.
But yeah, if you have 50 friends who want to buy it, as we said at the beginning, tell them now because we need their help.
Yeah.
And also, if this one isn't successful, then March.
Stay tuned.
Stay tuned. We're looking at March. That's the date that we've kind of got.
And we'll have different, as we mentioned before, different options. We've paid some attention to the feedback we got, and which we're really thankful for.
Yeah.
We are disappointed, but still super excited because even though we haven't been able to raise the funds from this campaign, the emails that we got and the all the responses that we got to various things we've posted have been really positive, and it seems like there's a lot of people who are really interested in this kind of a system. It's pretty unique. We think it's pretty unique.
Yeah.
And so we weren't giving up. I think there's a real future for it.
Yeah, for sure. So we'll be back. If not this campaign, next one. And as you saw, we've got a bunch of other exciting stuff in development as well.
And more we haven't even mentioned.
And there's other stuff that we haven't even talked about today. That's kind of in the back burner as well.
It's stuff that he hasn't even told me about.
Yeah.
It's probably going to be added to my to-do list.
All right, thanks.
I'm going to go have a beer.
Yeah, me too.
I'll catch you later.
We'll catch you on the other side.
Thanks everyone.
Thank you. Bye.